So first thing we're going to do today, we just want to review what we did last week. We'll be starting some new stuff this week. We will be using what we learned last week, the stuff with the simplifying square roots, to do what we're going to do this week. So it is important that you still know how to do this stuff. On this first part here, what are we going to do to simplify the square root of 27? We're going to start with a factor tree. So we factor the 27. How does that factor? 9 and 3. 3 is prime. 9 keeps going. 3 and 3, and those are both prime, right? Yeah. So we're going to rewrite the problem. When we rewrite the problem, what's the first thing we want to do?
Equal sign.
Yeah, we'll put an equal sign between our steps to show that the next step is equal to or has the same value as the problem itself. And then we need our square root, right? And then inside of the square root, instead of 27, we're going to put 3 times 3 times 3. All right, now what? Okay, we're going to circle our pairs. Remember, the pairs are squares, and a square cancels a square root out, so what's going to happen with that pair of 3's? Well, yeah, so the pair of 3's is going to become a 3 on the outside. So this 3 squared here is going to become a 3 on the outside of the square root because this square cancels the square root out. So we get 3 on the outside and 3 on the inside. We want to simplify the square root of 75. What are we going to do there? Start by factoring just like we did the last one. 75 cents is the same thing as 3/4, right? So it would be 3 times, how much is a quarter worth? 25, right? So 3/4 would be 75 cents. And then 25 is 5 times 5. All right, so then we're going to rewrite it again. So we've got our equal sign, we've got our square root, and then what are we going to replace the 75 with? 3 times 5 times 5. Okay, and then we're going to look for pairs. We have a pair of 5's, which is 5 squared. So the square is going to cancel the square root, and the 5 ends up on the outside. So we have a 5 on the outside and 3 on the inside. All right, last one, we want to simplify the square root of 600. So I'm going to start it off 6 times 100, and then 6 is what times what? 2 times 3, and then 100 is 10 times 10, and each of those 10s is? All right, so we're going to rewrite this one. This one will need a little bit of a bigger square root, right? So what's the prime factorization going to look like there? How many 2's do we have there? Yeah, I count 3. So 2 times 2 times 2 times just one of them? Okay, times 5 times 5. We got 2 of those. Okay. Also remember, when you finish writing this prime factorization, make sure that square root covers everything that should be in there. All right, next thing. Circle your pairs again. So we got a pair of 2's, got a pair of 5's, and that's it, right? So on the outside, what are we going to get? 2 times 5, which is 10. Okay. If you want, you can put another step in here and do the 2 times 5, or write 2 times 5 out there instead of 10. But we're just going to end up multiplying it together, so it's okay if you skip that step. And then on the inside, we have a 2 and a 3 left, so what are we going to have in there? 6. So we get 10 square root of 6. This question right here doesn't really seem to look like it's related, but it is. It's going to kind of help us with what we're going to do today. What can I do with this expression to simplify it, if anything? Octavian?
3a plus 5a.
Is? Yeah, so what Dartavian's saying is that we can combine the 3a and the 5a. Why can we do that?
Because they have the same variable.
They have the same variable. What do we call that?
Like
terms. So the 3a and the 5a are like terms because they have the same variable. The 4b is not, so we can't combine that, right? All right, so we're going to combine the 3a and the 5a, and we get 8a. So all we do to combine like terms is we add the coefficients, the numbers out front, right? So we add the 3 and the 5 together and we get 8, and then we just keep the a, the variable part, the same. All right. Then since I couldn't combine the 4b, should I just leave that off? No, we still need to put it on there. We're just going to tag it onto the end. But that's not going to change because we didn't do anything. We didn't combine it with anything. So it's still just a 4b. And that's as simple as the answer gets. Now, let me ask you this. Does it matter if we say 8a plus 4b or 4b plus 8a? So it's a trick question kind of because this means the same thing. So 4b plus 8a means the same thing as 8a plus 4b. It's just like saying that 2 plus 3 is the same thing as 3 plus 2. They're both 5, right? But since these have variables in them, we want to write them in a certain order. And the reason we write them in the same order is the same reason we write our prime factorizations from least to greatest. That way everybody's going to get the same answer. Can anyone guess what order we want to do this? Why would we choose 8a plus 4b instead of 4b plus 8a? Why is this one better? Somebody said it.
Because A is like the 4B.
Yeah, a comes to 4b in the alphabet. So when we have different variables, we're going to write them in the order of the alphabet, in alphabetical order. So the 8a will come first because a comes to 4b in the alphabet. All right, so just like anything else that we're doing, the order that we do things does matter. The reason we want to write these in a particular order is so that when you write your answer and somebody else writes their answer, and when I write my answer, they all look the same. So even though 4b plus 8a means the same thing, we're not going to write it that way.